If you've ever felt like Next.js caching is this powerful but kind of magical black box, you're definitely in the right place. In this explainer, we're going to crack that box wide open. We're going to demystify the entire caching system so you can make your apps faster than ever. Let's get into it.
You know, this quote just nails it, right? This is the core problem we're trying to solve. Every single time your server does the exact same work over and over again, fetching the same data, rendering the same HTML, it's like being a chef who just ignores a perfectly good, ready-to-go meal to start chopping vegetables from scratch. It's slow, it's inefficient, and honestly, we can do so much better.
So yeah, we're facing this caching conundrum. My goal here is super simple. I want to give you a clear mental model, a simple framework, so you can stop guessing, so you can confidently pick the right caching strategy for the job and just make your apps absolutely fly.
When you boil it all down, caching is about this one beautiful principle. Do the hard work once. Whether that's a big API call, a heavy database query, or rendering some super complex component, you do it one time, you save the result, and then you reuse it instantly the next time someone asks for it. It's the ultimate solution to our wasteful chef problem.
Okay, to really master this stuff, we need a map. A mental map. And here's how I want you to think about it. Picture the Next.js cache as 4 nested boxes, like Russian dolls. Each layer sits inside the other, and each one operates at a different level, starting from your browser all the way down to a single request happening on the server.
And here they are, our 4 nested boxes. We're going to move from the outside in. We start with the router cache, which lives right in the user's browser. Then we go a layer deeper to the full route cache on the server, which handles entire pages. Deeper still is the data cache for things like API results. And finally, that innermost box, request memoization, which works its magic just for a single server request.
Now, before you get overwhelmed trying to memorize all 4 layers, just relax. The 2 on the ends, the router cache and request memoization, they're mostly automatic. Think of them as your invisible helpers working quietly in the background. We're going to focus on the 2 in the middle, the ones that are powerful tools you can actively control, caching entire routes and caching individual chunks of data.
So let's grab our first tool. I like to call this one the sledgehammer. Caching an entire route is this big, powerful, broad stroke approach, and it is absolutely perfect for content that doesn't change for every single user. Think blog posts, product pages, that kind of thing.
The key to making this sledgehammer work is this idea of a static route. Basically, if your page doesn't need to know anything specific about the user, like their cookies or special request headers, Next.js can build it ahead of time. It pre-renders the HTML during your build process and caches it, ready to be served up in a flash. That's the foundation of the full route cache.
And here's the best part. You don't have to guess if it's working. Just run your build command, and Next.js will literally tell you the whole story. That little empty circle, that's a fully static, fully cached page. The lambda symbol, that means it's dynamic, build fresh every time. But that filled-in circle in the middle, oh, that's where the real magic is.
That filled-in circle stands for Incremental Static Regeneration, or ISR. And you guys, this is the brilliant bridge between the blazing speed of a static site and the freshness of a dynamic one. It really lets you have the best of both worlds.
So how does ISR work? It uses this clever strategy called stale while revalidate. A visitor shows up and bam, they instantly get the old cached version of the page. It's super fast. At the exact same time, in the background, Next.js starts rebuilding the page with fresh data. Once that's done, the next person to visit gets the brand new version. The most important part, the user never ever has to wait for that slow rebuild. It's seamless.
And you get 2 ways to control this. Time-based is the set it and forget it approach. You just export a revalidate variable and tell Next.js, hey, refresh this page every 60 seconds. Easy. On demand is for when things change unpredictably, like a user publishing a new post. You can trigger that revalidation to happen immediately with a simple function call.
Okay, so we've seen the sledgehammer for handling whole pages, but what if you need more precision? What if only a small part of your page needs caching? Well, that's when you put down the sledgehammer and pick up the scalpel. This gives you incredibly fine-grained control, and it's a huge innovation in modern Next.js.
This precision comes from a new superpower, really, which is React's built-in cache function. When you wrap your data fetching logic in this function, you're telling Next.js, hey, the result of this work can be saved and reused, and it can be reused across different components, totally independent of the page it happens to be on. This is a real game changer for how we optimize our apps.
So how does it actually work under the hood?
It's pretty clever. Next.js looks at the function you've wrapped and, crucially, the arguments you pass to it. It combines them to create a totally unique cache key. The next time that exact same function is called with the exact same arguments, Next.js just goes, I've seen this before. It finds the matching key and serves up the saved result instantly without running any of your code again.
When you're caching data like this, especially with fetch, you've got a simple little toolkit. You can set a revalidate time in seconds to say how long the data should be considered fresh. You can also add tags to your cache entries, which is like putting little labels on them so you can find them and invalidate them later. And what's really powerful is this works for any data source. Wrap a direct database query and React's cache function, and you're good to go.
Okay, now listen up, because this is probably the most important rule you need to remember. A cached function is designed to be reusable across many different users and requests, right? So it cannot directly access request-specific stuff like cookies or headers. If it needs that information, the parent component has to read it and then pass it down as an argument or a prop. This is critical for making sure your cache keys are correct and everything stays secure.
All right, we've talked about the big sledgehammer and the precise scalpel. So now for the million-dollar question, when do you actually use which one? Let's tie it all together with a super simple decision framework that's going to make this crystal clear.
Here we go. This is the cheat sheet. If you want to cache a whole page on a timer, you're going to use route level revalidate with ISR. If you're caching data from an external API, the extended fetch options are your best friend. Caching a database query or some heavy data for a component, wrap it in react.cache. Need to clear out old data after a user does something? You'll use revalidateTag or revalidatePath. And finally, if you just want to avoid fetching the same data multiple times during a single render, React's cache handles that for you automatically. Simple as that.
So, with all these awesome tools at our disposal, what's the right strategy? How should we think about this? Well, it can all be distilled down into a simple, really effective caching philosophy.
Here it is in 3 steps. First, always start simple. Use the sledgehammer. Use ISR wherever you possibly can. It's so powerful and it's so easy. Second, only get granular when you really need to. If you have a mostly dynamic page, but one specific data fetch is slowing it down, that's when you reach for the React cache scalpel. And finally, tag everything. Getting in the habit of using tags from the beginning gives you the power to invalidate your cache with surgical precision later on.
And that's our tour. You now have the mental map of the nested boxes. You know when to use the sledgehammer and when to use the scalpel. So the only question left is, when you look at your own app, what part of it could you make faster tomorrow?